there are 2 moles of hydrogen iodide which are involved in the reaction. So that molecularity will become 2. Molecularity will be always, it is a whole number. It cannot be 0, but the order will be also become 0. K is equal to 2.303 divided by T into log of R naught divided by R. This is the equation, that is integrated rate equation for the first order. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, welcome back to the revision class of 2nd PUC Chemistry. In this session, we are going to discuss with the Unit 4 Chemical Kinetics. Before going to discuss with this unit, let's see the weightage of this unit. From this unit, we can expect 11 marks. So, how many marks will be allotted for this unit? 11. If you see the weightage, in the part A, the question number 5 will come from this unit which carries 1 mark. Similarly, in a part D, the question number 39 and 40 will come from this unit. So, there are 3 questions will be there and one is 1 mark question and there are 2 5-mark question will be there and totally we can expect 11 marks from this unit. So, what we are going to discuss with this unit? We are going to discuss with the again 1 mark, 2 mark and a 3 mark. Remember this 3 mark which is nothing but a 3 plus 2 question. That is why I have put it as a 2 marks and a 3 marks. Okay. We'll see how the question will be raised in the 1 mark. Okay. Let's see the example. For a reaction to hydrogen iodide, give rise to the hydrogen and iodide, write its molecularity. If you see the molecularity of the reaction, you can clearly understand that there are 2 moles of hydrogen iodide which are involved in the reaction. So that molecularity will become 2. So answer is 2. Okay. What happens to the half-life period of the first order reaction if the initial concentration of the reactant is increased? So what will happen to the half-life period of the reaction even though you are increasing in the concentration of the initial concentration of the reactant? It does not change at all because it remains same. Okay, because the half-life period for the first order reaction is independent on the initial concentration of the reactant. That is why it does not change and it remains constant. Okay. Next question will be goes like this. Mention any 2 factors which influences the rate of the reaction. So, the rate of the reactions will be affected by one is temperature, another one is concentration of the reactant. So, these 2 factors which always determine the rate of the reaction. Okay, one is concentration of the reactant, another one is a temperature. Okay. Next question will be goes like this. What is the SI unit for the 0 order reaction? So, remember like this, they can also ask you to write the SI unit for first order as well as with a second order reaction. So, usually they'll ask with the 0 and first order. Okay. So, the SI unit for the first order is mole per liter per second. Mole per liter per second. Next question will be goes like this. A chemical reaction has a rate expression which is equal to concentration of the A square into concentration of the B. What is its overall order? If you see the overall order will be obtained by adding the sum of the powers. You can see that the concentration of the A is 2, the concentration of the B is 1. If nothing is there, which indicates that it is 1. So, it is 2 plus 3, it is nothing but a 3. So, what is the order of the reaction? It is 3. Okay. So, how do we calculate the order? Just by summing up the number of powers of the reactant molecules which are involved in the reaction. Okay. Next, rate of the reaction A which gives rise to the B, which increases the 2 times by increasing the concentration of the A by 4 times. What is its order of the reaction? You can see that they have given the rate of the reaction where A is giving rise to the B. Okay, A is giving rise to the B, and which is 2 times of increasing the concentration of the A. Okay, and also which is 4 times of that of the A. So it is 2 by 4, it is 1 by 2, and you can clearly say that it is 0.5. Or you can write it is 1 by 2 or 0.5. So this is the answer. Next, we'll see with the 2-mark question, because from this unit there is a 2 5-mark question will be there. We must know that how the question will be arises in the 2-mark as well as in the 3-mark. Okay. First I'll go with the 2-mark question. What is the zero order reaction? Give an example. You need to write the statement for the zero order and you need to give a one proper example, and that should be balanced. Okay. The reaction in which the rate is independent on the concentration of the reaction, then it is said to be a zero order reaction. So here we have an example where the ammonia is catalyzed by the platinum and at very high temperature around 1130, and it is giving rise to the nitrogen and hydrogen. So it is a preparation of ammonia by Haber's process, or you can rewrite this reaction also as nitrogen plus hydrogen give rise to platinum as a catalyst at very high temperature, which gives rise to the ammonia. So this is a preparation step for the ammonia by Haber's process, where the nitrogen and hydrogen which has been prepared, which has been combined to give a ammonia. Okay. So you need to show that the reaction in which the concentration of the rate of the reaction which is independent on the concentration of the reactant. Okay. Next, explain pseudo first order reaction with an example. Again here you need to tell what is a pseudo first order reaction and you need to give a one proper example. Okay. The higher order reaction can be converted into first order by changing the experimental conditions are said to be a pseudo first order reaction. So usually pseudo means it is a false. Even though the reaction is not a first order, it is behaving like a first order. Such reactions are said to be pseudo first order reaction. Okay. So the higher order reactions can be converted into first order just by changing the experimental condition. You are just changing the experimental condition to behave the higher order reaction to the first order, and that is said to be pseudo first order reaction. Example is inversion of sugar. You can take that the example of the cane sugar, which is upon hydrolysis with the water, it gives rise to the glucose and fructose. Okay. This is a simplest example. Even though the reaction is not a first order, but it is behaving like a first order. Hence, it is named as pseudo first order reaction. Next, give any two differences between order and molecularity. So, any two differences is enough to get a 2 mark. Proper one you must write. Okay. So, see, order we know that it is obtained by just counting the sum of the powers of concentration terms which is involved in the reaction. Correct? No, it is the sum of powers of concentration terms involved in a rate equation. And you can see that molecularity is nothing but a number of reacting species which are taking part in the reaction step. And it can be 0, even the fraction, but the molecularity will not be 0. Whereas the molecularity will be always, it is a whole number. It cannot be 0, but the order will be also become 0. Okay. And coming into the order, it is a experimental quantity, it is a theoretical quantity. Any two proper differences if you write, it's enough to get a 2 marks. Hope you all understood. Here I have listed out the 4 differences. Any 2 differences you can write it on your exam. Next, Define half-life period of the reaction. Half-life of the reaction can be defined as the time required to convert the half of the reactant into the product. It is said to be half-life of the reaction. So, which means to say that if A is giving rise to product, imagine A is a reactant. What is the time which is required in the half period, or in the what is the half of the time which is required to convert that reactant A into B product? That is said to be half-life period. Okay. Next, coming into the 3-mark question, from this unit we can expect a derivation, that is the integrated rate equation for the zero order, and also we can expect the integrated rate equation for the first order. So, any one of the integrated rate equation definitely they are going to give for your examination. Other one will be mainly based upon the numericals. Okay. And that too we will see how to solve with the numerical. First we will go with the derivation. Okay. Derive an integrated rate equation for the first order reaction. So, you need to write what? Integrated rate equation for the first order reaction. First order reaction is a reaction where the rate of the reactant is proportional to the first power of the concentration terms of the reactant which are involved in the reaction. Imagine R is a reactant which is giving rise to the product P. If you see that rate equation, rate is equal to minus D into concentration of the R divided by dt, which can also be written as K into concentration of the R. Just you rearrange these two and you can rewrite it as D by R divided by dt, which is equal to K into dt. Now for this equation 1, if you integrate on both the side, you will get ln of R, because the integration of dr divided by dt, which is nothing but a ln of R. Okay. So, ln of R into the integration of k dt, which is nothing but a k into t plus I. Okay. So, integration on both the side, you will get a ln R minus k into t plus I. So, I represents the integration constant. Now, after getting this equation 1, now I will consider the time as t 0 and R as a R naught, and above equations can also be written as ln R naught, which is equal to minus k into 0 plus I. Okay. So, ln R naught, which is equal to I. This is another equation as I got. Now, if you substitute the 2 in the last equation, you will get ln R, which is equal to minus kt plus ln R naught, or kt if you take it outside, it will become ln R naught minus ln R, or k is equal to 1 by t into ln of R naught divided by R, or you can see that if you wanted to remove this ln, you need to multiply it with a 2.303. So, k is equal to 2.303 divided by t into log of R naught divided by R. This is the equation, that is integrated rate equation for the first order. Okay. So, this is how you need to write the integrated rate equation for the first order. Next, derive an integrated rate equation for the zero order reaction. Let's see how to derive an integrated rate equation for the zero order. For the zero order reaction is the one in which the rate of the reaction which is independent on the concentration of the reactant. So that we can rewrite the reaction as R is giving rise to product, and rate equation for the above equation is minus dr divided by dt is equal to k into R naught. Now, any quantity can be raised to the power is 0, in the sense it is always equal to 1. So that the rate equation will be equal to minus dr divided by dt is equal to k into I. Okay. Now, if you replace with the t, you can rewrite it as d into r, which is equal to minus k into dt. Now, if you integrate, dr is equal to integration of minus k dt, you will get r is equal to minus kt plus I. Okay. This is the equation 1, where I stands for integration constant. Now if I consider time is equal to 0 and R0, which is nothing but a initial concentration of the reactant. Now if you see with the overall equation, R0 which is equal to minus K into 0 plus I. So R0 is equal to I. Now after getting the equation for the I, you substitute for the earlier equation. So you will get R is equal to minus KT plus R0. Now if you simplify further, if you have taken out the K outside, then you can rewrite this equation as R0 minus R divided by T. So this is the integrated rate equation for the zero order. A final equation we are repeatedly using for deriving for the half-life of the first order as well as for the zero order. Okay, and also while solving the numericals also it is very important to know this formula. Next, derive an expression for the half-life period of a first order reaction or show that half-life period of the first order reaction is independent upon the initial concentration of the reactant. So you need to derive what? First order half-life of that equation. So we know that the first order integrated rate equation is equal to K is equal to 2.303 divided by T into log of R0 divided by R. Now we are considering what? Half-life period. So I will consider T as T of and the concentration of the R as R0 divided by 2, because the concentration of the R is nothing but a reactant concentration, which is always equal to the initial concentration of the reactant by 2. So above equation can also be written by applying this. Okay, so we can rewrite it as K is equal to 2.303 divided by T half into log of R0 divided by R0. Now R0 will be get cancelled. So T half if you are taken out and K will becomes here. So T half is equal to 2.303 divided by K into log 2. Log 2 value is 0.301, and now if you multiply it with the 2.303, it will become 0.693 and TF is equal to 0.693 by K. Again, this is very important for the examination point of view, because this final equation can also be used to solve the many problems. Okay. Next, derive an expression for half-life period for the zero order reaction or show that half-life period for the zero order reaction is directly proportional to the initial concentration of the reactant. First, write the integrated rate equation for the zero order. K is equal to R0 minus R divided by T, or T we consider as a T half, and concentration of the R will be equal to concentration of the R0 by 2. Now the above equation can also be written as R0 minus half into R0 divided by T half, and you can rewrite it the T half into is equal to R0 divided by 2K. This 2 will be comes to the denominator and become a 2K. This is a final equation to represent the half-life period for the zero order reaction. Remember, so integrated rate equation can also be asked for 3 marks, but this half-life period sometimes they'll ask for 3 marks, sometimes can also be asked for 2 marks. That is why I have mentioned in the 3 marks. So please be careful. If they ask you to write for 3 marks, you need to write it neatly and with a final equation. Okay. Next, a certain first order reaction is 75% is completed in 30 minutes. Calculate the rate constant. Calculate what? Rate constant. So we all know that it is a first order reaction. So what is the integrated rate equation? Still that K is equal to 2.303 by T into log of concentration of the R0 divided by R. Correct? And what is the first order reaction is 75% is completed in the sense. So here they have given the first order reaction is 75% is completed. Correct? No? So here the concentration of the R is given by 100 minus 75. It is nothing but a 25. What is the R0 value they have given? It is nothing but a 75, and that too it is in the percentage. Now the time is given, that is 30 minutes. Now if you substitute 2.303 divided by 30 into log, so R0 value will be 100. Why it is 100? Because it is a overall reaction where the reactant is giving rise to product, correct? No? And after the completions, you know, it has a 75%. So I have minus with a 75, you get a 25 and R0 value will be 100. So log of 100 divided by log 25. Now 2.303 divided by 30 into log of 4. So you will get log 4 value as 0.6021 to 2.303 by 30. You can multiply these two and you can divide with the 30. 0.04322 per minute. And this is the final equation. Okay. This is how for writing the formula and for the substitution. For formula it is 1 mark, for the substitution and for the final answer you will get a 1 mark, 3 mark total. Okay. So hope you understood with the types of questions which has been asked repeatedly from this unit 4 chemical kinetics. I'll come back with the next unit. Till that, take care, be safe. We'll meet you with the next session. Thank you.